Welcome. Let's go. Example number 1. This is part 3 of the video on chemical kinetics. We'll be dealing with various calculations under what we have been doing so far. Practical examples. Now, you have this question, and they gave you this equation, and you can see that hydrogen is being formed at the rate of 0.02 mole per second. Now, the question is, calculate the rate of decomposition of ammonia. Now, look at from the question, you can see that ammonia is a product, that means it's decreasing, it's disappearing, while nitrogen and hydrogen is increasing. Now, of course, following the part 1 and part 2 of the video, the overall rate of reaction, I've already written it here. You can see I've included minus here. Why? Because this is disappearing and these two are appearing. Now, from here, on the question, they made it easy. Now, they gave you the rate at which hydrogen is formed. That means that the H, they gave it to you to be 0.026, 0.062, right? Now, the next thing for you to do, this is so easy. If you start understanding this, you don't have issue again. They gave that of the hydrogen, so this is just the T, they gave you E all over the T to be this. Now, they want you to know that of the ammonia. Remember, I told you in part 1 of the video that the rate of disappearance is the same thing, is equal to the rate of appearance. I said it. The rate of disappearance is equal to the rate of appearance. Now, all we need to do is, since we have written the general rate of reaction, we will just equate them together and the answer will flow naturally. Look at what I'm saying. They gave you hydrogen, and they want you to get out of the ammonia from this. All you need to do is, remember, the rate of disappearing, they are all equal to each other. So from here, this is just minus 1 all over 2 T, this is ammonia, all over the T, is equal to that of the hydrogen for the general rate of reaction is 1 all over 3 all over the T. Now, but you already have this. So all you need to do right now is make one of the ammonia the subject of the formula and insert, and your answer will flow just naturally. This is so easy. You can simply just pause the video and solve it yourself. So all I need to do right now, I want to make the ammonia, the rate of disappearance of ammonia, the subject of the formula. So this will go this way. So this will give me which is 1 all over the T of the hydrogen all over the T. Now, I'm going to divide it by minus 1 all over 2. In mathematics, that's what we call the keep, change, flip. The keep, the change, the flip. Now, when you have a denominator that appears like this, I'm going to keep this one. I will change this sign, this division. So this division will turn to multiplication, and I will flip this one. So we call it keep, change, and flip. Keep, change, and flip. So this will be minus 1 all over 3 hydrogen all over the T. Now this division will change to times multiplication, and I'll flip this. So this will give me minus 2 all over 1. So from here, this is just this times this, and you divide it and you get your answer. So the one of hydrogen is, this is minus 1 all over 3, 0.02, right? So you times it by 2 and divide by 3. So if you punch minus 0.062 times 2 divided by 3, what you will get is, your answer should be minus 0.04. And remember, it is in molarity per second. So it's in molarity per second. Now, if this keep, change, flip is giving you an issue, remember this course is either OBJ or sub-objective. All you need to do is immediately you come to this side and get it like this. What you will do from here, you are copying this side, right? See what you will do, because like I said, it's either OBJ or sub. All they need is the answer. See what you will do immediately you come to this side. Since you are out of the hydrogen, you just put it like this, 1/3, and then this is 0.062. So if you press it in your calculator, whatever answer you get from here immediately, you just carry it and times by 2 and include the minus, you still get this answer. So I'm just trying to take my time for you to understand it. But if it was an exam, I will not even reach here. I'll just insert this, divide it by 3, times it by 2 immediately, and then you make this already studied of the formula from here. So learn it very well, please. Now let's go to the example, the B part. Calculate the rate of formation of nitrogen. The rate of formation of nitrogen from the question, you can see that nitrogen is plus. So all you need to do is, from here, remember, let me clean this. That of the nitrogen, this is nitrogen, this is oxygen. So the N all over the T is equals to 1/3 all over the T. Now we have that of the hydrogen already. Let's not waste time. This is 1/3 times 0.062. Now if you punch it in the calculator, you should get 0.02 molarity per second. Fast, doesn't waste time. And you can see that from this, the answer is plus. Why? Because the nitrogen is at the product side, so it's forming. So that is so easy. Now the next one is calculate the rate of reaction at the time interval. Please, if you are the kind of student that like, if you punch calculator, you get exactly the same thing. This place should be 0.021. The other one, this is my answer, I got should be 0.041, because a lot of people will meet me and say, sir, I punched my calculator, I did not see this exact same thing. So if you're that kind of student, just know that I just neglected that one, but it should also be there. So I just want to let you know. Now, for you to calculate the rate of reaction, any of this rate of disappearance or appearance, you can simply use it to calculate the rate of the reaction. So it's not that difficult. We already have the overall rate of reaction there. All you can do is just put in any of those values there. You will still get your answer. Remember, we did that of this. I can just pick any of them. I will still get the same answer. From the beginning, look at it. I said the overall rate of reaction is this. It's supposed, if I any of these ones, any of these values, R is equals to minus 1/2 into that of the nitrogen. And what is the answer we got at that of the nitrogen? I think is 0.04. So we have 0.041. If I divide it, I will get 0.021. If I still insert that of the nitrogen here, and that of the nitrogen, what did I get? That is also 0.021. That of the hydrogen is already given, 0.062. If I divide it by 3, I will still get this answer. Why? We said that the rate of disappearance must be equal to the rate of appearance. So any of these value, if you already got it and you divide it by the coefficient, you should get the rate of reaction. And all of them, all the three equation I wrote here from the general rate of reaction, this. Whichever one you insert the value and divide it by the coefficient, you will still get this same answer. Please don't forget the SI unit, molarity per second. Wahala for who I just wrote molarity per second. All you know is mole per. All you know is mole dot liter minus 1 dot s minus 1. You don't know this one. That means the part 1 of the video you did not watch it, and that is wahala for you. Let's go carry on ahead. So please note this thing very well. You can see I'm taking my time to explain this so that someone will not get confused. When we saw the rate of this, we got minus 0.041. If you times it, do not forget this minus. We times it and divide, we get plus 0.021. This is already on formation. When we divide it, we still get 0.021. Any of this equation, that any of these value that you insert, you will still get the same rate of reaction. I want to emphasize because I don't want you to, where you're supposed to put minus, you will forget and you will not put it. At the end of the day, you will get this answer to be minus, while the other answer will be plus. So please always note it and apply it where necessary. We are in the next example. You have an equation and they ask you what is the rate of reaction in terms of change in water with time, and O2 is decreasing at 0.23. Now the first thing I'm going to do is I'm going to write the overall rate of the reaction. So which is the rate is the quotient of 2 minus 1 all over 2, the hydrogen all over the T, which is equals to minus all over the T, which is equals to plus 1 all over 2 the water all over the T. Now, we already have the initial rate. Now, let's concentrate. What is the rate of reaction in terms of water? And they gave you this concentration of oxygen to be this. So, you have oxygen. Now, what they want is that of the water. And remember, I said the rate of appearance is equal to the rate of disappearance. So, if you should focus on only oxygen and water, what we are going to do is to make that of the water subject of the formula. So from here, we have 1 all over 2 concentration of water all over time to be equal to minus the oxygen. Now what I want to do, I want to make this sort of the formula. So in short, for shortcut, if you are in the exam, immediately you set it this way. Just carry the coefficient and times here immediately. Carry the coefficients, flip it and put here. So if I'm in the examination hall, I'm not going to be wasting time writing all this. Immediately I write it like this, I'll just carry these two, flip the sign. It will just be times 2 all over 1 immediately, and I'll put it and get my answer. I'm only taking my time to do it because I want you to understand it very well. So as you're understanding it, also understand the shorter method, because like I said, Chem 131 is mostly OBJ or sum. They only want the answer. So from here, if I want to make this subject of the formula, this will be minus this oxygen all over the T times 2 all over 1. Now, that of the oxygen, remember they said is decreasing. Is decreasing. The initial concentration of oxygen must be minus. Look at it, must be from here. The other said is decreasing. So that means all over the T must be minus 0.23. Now, remember, also in the formula we have 0.2, we have minus also in the formula. So that's why I say you have to be careful. Never forget that whenever something is disappearing, that the concentration must be minus, even if they do not give you, even if they do not state that it's decreasing. Immediately they write it, but you know that it's at the product, it's at the reactant side, you must include minus immediately. So when this minus, jump this minus in this formula, so we have, so this, your answer will now be all over the T to be minus. Now the concentration of oxygen given in the question is also minus 0.23. And you see that minus times minus will give you plus, right? So this is, remember for the formula, plus 0.23 times 2. Now we're going to have to times it for we to get the answer. And that should give you 0.46. That should give you 0.46. So here, the answer here is 0.46 molarity per second. Like I said, this is the easiest way for you to do it. The more I keep on solving practical example on this course, you understand it more. Please understand both the shorter method and this one I'm taking my time to do. And always remember, I will repeat it again because it's very important. Because over the years, if you forget that this is at the product reactant side and you forget to put minus, your answer will not be minus, which is not possible because they want you to calculate that of the water, and water is at the product side. It must be plus. Your answer must be plus. So if you forgot to include the minus here, at the end of the day, if you times it, you will not be getting minus. Are you now saying the product is decreasing? So that's why I'm taking my time to emphasize on this, because I've seen it, people having issues with it. You will get the answer, but the sign becomes the problem.